Now in this video, we will discuss problem related to Newton's second law and motion of connected particles. We have one example here. Question says, two particles of mass 5 kg and 3 kg are connected by light inelastic string passing over a smooth fixed pulley. So here we have, this is the fixed pulley and mass of one is 5 kg and mass of another object is 3 kg and a string is inelastic. So string is inelastic and the pulley is a smooth. So this is given to us. We have to find the acceleration of particles and tension in the string when the system is moving freely. So we have to find tension in the string. We have to also find acceleration of the system. Now 2 points is important. When this pulley is smooth, tension this side is equals to tension this side. But when pulley is not a smooth, tension both sides is not equal. So I can say when pulley is a smooth, tension in both sides, in both a string will be same. That is, if this string has tension T, then this string also has a tension T. Now another important point we have, since a string is inelastic, so a string cannot expand or it cannot be stretched. So this means if this mass is going down by some length x, this mass also has to go up by length x because a string is inelastic. So I say acceleration of this block and acceleration of this block is same. So now important point, since a string is inelastic, acceleration of both block should be same. Now we can draw free body diagram. So now what are the forces that is acting? So mass mg, that is 5 into z. Here also we will have mass mg, that is 3 into z. Now this string is basically try to pull this up. So tension in this string T is up. Tension in this string is also T up. Now this is a heavy mass, so let us say this is going down by acceleration A and this is going up by acceleration A. We can write free body diagram equations from this free body diagram. So what we have, this mass is going up, so let us say up forces are positive, so T minus 3z is equals to mass into acceleration. So mass is 3 and acceleration is A. If I write equation for this mass is going down, so let us say downward as positive. So force in the downward direction is 5z minus T is equals to mass into acceleration. So mass is 5, acceleration is A. So we have these two equations. Now we can solve these two equations. Let us add these two equations. So I will have this 3z, so t cancels out, so 5z minus 3z, that is 2z is equals to 8a. So acceleration will be z by 4 meter per second square. Now similarly we can find tension. So let us say put this value of acceleration in equation 1. So now I can write, or equation 2, any one you can use from equation 2, we can have 5z minus t. This is equals to 5 times z by 4. Acceleration is z by 4. So t is equals to 5z minus 5z by 4. This is equals to t. So if I solve this equation, so t is equals to 20 minus 5 z, and this divided by 4. So this is equals to 15z by 4. So this is the tension in the string. So tension is 15g by 4 and tension will be in Newton, and this acceleration is meter per second square. If you wish, you can do the same problem in terms of variable m1 and m2. Let us say, if I do the same problem, let us say mass of this object is m1 and the mass of this object is m2. So we can find again acceleration. So let us say this is going down with acceleration a and this is going up with acceleration a. And the free body diagram, we can write forces. So their force is m2z, and there we have a force m1g in the downward direction, and there is a tension T, and there is another tension T. Both tensions should be same. Now let us write equation for this object. So we can write m1z minus T. So let us say this object is going up, so upward force we have to take positive. So this is T minus m1z is equals to mass is m1 into acceleration. For this object we can write mass is going down, so m2z minus t is equals to mass into acceleration. Now if I add these two equations, we will have m2 minus m1 into z is equals to m1 plus m2 into a. So from here we can calculate a. So a is equals to m2 minus m1 divided by m1 plus m2, and this multiplied by z. So this relation you can remember. Now let us find tension from equation 2. So this is my equation number 1. This is equation number 2. So let us find tension from equation 2. So tension is m2z minus t is equals to mass, that is m2, acceleration is m2 minus m1 divided by m1 plus m2 into z, m1 plus m2 into z. So if I take this side, so I will have m2z minus m2 into m2 minus m1 into z divided by m1 plus m2. This is basically equals to tension. So if I take m2z common, so here I can take m2z common. So if I take m2z common, I will have 1 minus m2 minus m1 divided by m1 plus m2 into is equals to t. Or if I simplify further, so t is equals to m2z, and here I will have m1 plus m2 minus m2 plus m1, and this divided by m1 plus m2. So now this m2 goes, so I will have 2m1. So tension is equals to 2m1 m2 divided by m1 plus m2, and this multiplied by z. So this is the tension in the string in terms of variable m1 and m2. Another important point, what is the force that this system is applying on the roof? So this is my roof. So if somebody asks what is the force that is applied on the roof, so if you see this pulley is massless, so there is a tension in the downward direction is T, there is a tension in the downward direction T. Let us say if I have a tension here T dash, so we can verify for this system, this is a massless system, we can write force upward direction minus downward direction force tension T and T, so that is 2T, and this acceleration is 0, mass is 0 basically. So T dash is equals to 2T. So force on the roof is 2T. So we can write here, so system applying a force on the roof is equals to force on the roof. This is equals to 2T, and that is basically 4m1 m2 divided by m1 plus m2, and this multiplied by z. So this you can remember. Now this is another problem related to connected motion. Question says a particle of mass 2 kg rests on the surface of rough plane which is inclined at 30 degree to the horizontal. So we have this plane and this mass of this object is given. So this mass is 2 kg, that is given to us, and the inclined plane has an angle of 30 degree. This is also given. It is connected by a light inelastic, a string passing over a light smooth pulley at top of the plane. So this pulley is smooth. This means tension in this string and tension in this string is same. This pulley is light as well as smooth, and the string is inelastic. This means acceleration of this block is same as acceleration of this block. To a particle of mass 3 kg which is hanging freely. So mass of this particle is basically 3 kg. If the coefficient of friction between 2 kg mass and the plane is 1 by 3. So coefficient of friction for this surface that is given, that is 1 by 3. Let us say this is equals to mu is equals to 1 by 3. Find the acceleration of system when it is released from the rest. So first let us find acceleration. We have to also find what is the tension in the string. So tension. Finally we have to find what is the force exerted by the string on the pulley. So this is a string and this is a string. What is the force exerted by these strings on this pulley? So let us find force on pulley. So force on pulley. So let us discuss one by one. First let us draw free body diagram. So since this mass is heavy and this mass is lighter, so it has a tendency to go in this direction. So mass mg, that is 3g, is acting downward, and let us say acceleration of this mass is a in the downward direction. So acceleration of this mass is also a because a string is inelastic. Now in this string there is a tension, that is upward, and in this string this is trying to pull, so tension is acting in this direction. For this mass we have another forces mg, that is acting downward direction. Mass is 2, so this is 2g, and on this mass there is a force that is acting normal reaction also. So let us rub this one. So there is a force normal reaction, so this force is acting up. So normal reaction is acting up. So this is the normal reaction, slightly difficult to make. So this is the normal reaction we have. Now there is a friction force. Since this block is going up, so friction will try to oppose the motion. So friction force will come in the downward direction, and it is equals to mu times n, and mu is 1 by 3, and n we have, so mu times n. Now what we will do to write equations, we will break this mg 2g along the perpendicular and along as well as perpendicular. So 2g will have component, one component in this direction and one component in this direction. So let us say make separate diagram for 2g. So this mass is 2g. What are the forces that is acting? This is 2g, and this angle is 30 degree. Let us draw a perpendicular over this surface. This angle is again 30 degree because angle between line is equals to angle between perpendicular. On this line this is perpendicular, on this line this is perpendicular. Now break this 2g along the incline and perpendicular to incline. So in this direction we will have 2g cos 6 30, and in this direction we will have 2g sin 30. Now in this direction we have normal reaction n, and this direction we have another force mu times n, that is 1 by 3. Friction coefficient is 1 by 3 times n, and there is a force acting tension for this block in this direction. So let us write equation for this block. Mass of this block is 2g or 2 kg. So mass of this block is 2 kg. So let us write equation for this block. This block is going up in this direction with acceleration a. So first in this direction force is t. So minus, in this direction we have to take negative. So 2g sine 30. And we have friction force also opposite. So 1 by 3 into n is equals to mass into acceleration. So mass is 2 and acceleration is a. If we simplify more, so this is t minus 2z, and sin theta is 1 by 2 minus 1 by 3 into n. This is equals to 2a. So we will have t minus z minus n by 3 is equals to 2 by 2a. So this is my equation number 1. The second equation we can write from here, normal direction. That is, in this direction there is no acceleration, so force n is equals to 2g cos 30 degree. So we can write n is equals to 2g cos 30 degree. And if I plug the value of cos 30, so we will have n is equals to 2z cos 30 is nothing but root 3 by 2. So basically n is equals to root 3 times z. So this is my equation number 2. One equation I will get from here, that is mass is going downward, so 3z minus t is upward, so 3z minus t is equals to mass is 3 and acceleration is a. So we have these three equations. We have three unknown. What are the unknown? We have t is unknown, we have normal reaction is unknown, we have acceleration is unknown. So there are three unknown, t, n and a. We can solve for these two. So if I plug the value of n in equation number 1, so we can write equation 1. So equation 1 will be t minus z minus n by 3, n is root 3z by 3 is equals to 2a. Now let us say equation 3 we have, and this is 3z minus t is equals to 3a. If I add these two equations, we will have 3z minus z, that is 2z, t goes, and minus this is 1 by root 3, so z by root 3 is equals to 5a. So from here we can write this is 2 root 3 minus 1 divided by root 3 into z is equals to 5a. So acceleration is equals to 2 root 3 minus 1 divided by 5 root 3 into z. So this is the acceleration of the system. Now it is used to find tension. So if I see in any one of the equation, we can plug the value. Let us say if I use equation 3, so equation 3, if I plug the value of tension, equation 3, so we have 3z minus t, so 3z minus t is equals to 3a, so 3 times a, that is 2 root 3 minus 1 divided by 5 root 3 into z. Now so from here we can calculate 3z minus this sign, this comes this side, so 2 root 3 minus 1 5 root 3 is equals to t, and this multiplied by z also. So t is equals to, if I take 5 root 3 as LCM, or we can basically cancel this, so 3z minus, so same thing can be written as 2 root 3 minus 1 into root 3, because root 3 and 3 cancels out, divided by 5 is equals to t, and this multiplied by z. So this becomes 15z, and this is all calculation, minus, and this is minus 2z, this is z, because 2 root 6z, basically root 3 into root 3 3 and 2 6z, and this is minus minus plus we will have root 3 z divided by 5. So finally we'll have 9 plus root 3 by 5 z. So this is the tension in the string we will have. Now the next part is we have to find resultant force on the string, or basically on the pulley. So if you see what are the forces acting on the pulley, so there is a tension in this direction and there is a tension in this direction. So these are the two forces, and this angle, if you extend, this angle is 90 degree, this angle is 30 degree, so this means this angle is 60 degree. Now these two forces are equal, so the resultant will pass through the middle, that is bisector. So resultant will bisect these two forces. So basically what is happening here, so we have two forces, one force tension is acting in this direction, another force tension is acting in this direction, and this angle is 60 degree. So this angle is theta is equals to 60 degree. So resultant will bisect. So this is the resultant. And what is the magnitude of resultant? So magnitude of resultant is, if you remember, force F1 square plus F2 square plus 2F1 F2 cos theta. So that is T square plus T square plus 2T1 T2, that is 2T square cos 60 degree in this case. So this is 2T square plus cos 60 is 1 by 2, cos 60 is 1 by 2, so 2 cancels out, so this is simply root 3t. And we know the value of t, so this becomes root 3 times 9 plus root 3, 9 plus root 3 by 5 into z. So this is the resultant force on pulley. And this will pass through the bisector of these two lines. So if I have this line and this line, it will pass through the bisector of these two lines, that is this angle has to be 30 degree. You can also say what is the angle from the horizontal. So you see, from the horizontal this angle is 30 degree, this angle is also 30 degree. So this angle is 60 degree. So from horizontal resultant is making a 60 degree angle, and from vertical resultant is making a 30 degree angle. So we can say from vertical resultant makes an angle of 30 degree. So this is all about the constrained motion. So motion that is constrained, and we can apply Newton's second law.